Amazing. Right, hello everyone, welcome to another stream. Welcome to day 2 of Man Shall Not Live Forever Alone. There's a little game we're working on as part of Hero Studios here. And there is a video up on the YouTube channel if you want to see what the game is about, what the plan is for the game, and what we'll be working on over the next kind of 6 months, I guess. We'll see how long that goes for. But we're in the prototyping phase right now. And we're currently working on trying to get a procedural map being generated. But before we do the actual procedural part, well, it is already procedural, right? But it's just a grid. There's not much logic to it. But we're trying to make it such that it will be able to scale to have a large map, and we can render enough blocks. So we've currently got like a voxel. Yeah, we've currently got a voxel map, and each one of these is not a voxel, it's actually a kind of a tile, if you will, a block of many other voxels. And because the debug camera, we can zoom in and you can see those blocks. So they're currently 16 by 16 here. So here we should be able to do different kind of heights and stuff and all of that. But we'll decide how many voxels inside a block at some point. But yeah, so what you'll see here is there is a bunch of these little this is the wireframe mode. There is a bunch of little boxes which are drawn around each of these and ray traced against. I'm seeing that they might be a little bit bigger than they should be. I should look into that. But there's that. Oh, damn. Cool. Right, so the problem is with current renderer is it doesn't allow us to efficiently cull objects that are not visible on screen or which are behind something. And this is going to be a problem with the map. So say we have a map which is 1,000 by 1,000, and we want to basically not draw all of that map. We also want to send all of that map to the renderer, and we might have like buildings which go up, and you don't really want to spend time to draw the things which go behind the buildings, right? So if there was a building in the middle of this map, you don't want to draw the blocks which are behind it and save space. But there was a problem that I was bumping into last stream where we have a maximum number of right, let's restart this because my cursor's gone. I need to fix that bug. But if we go to the image viewer, we have this thing called a visibility buffer, which is this, where it basically encodes in, kind of looks like noise, but effectively it encodes the instance index and a voxel index inside that block, basically. And there's only so many bits that are supported. So if we go to graphics vk shared.h, encode, there's a triangle instance reference. So this is the thing which gets thrown into the visibility buffer of 32 bits. So we just render a depth and this 32-bit integer. It's got a kind on there to tell us that it's a voxel and not a mesh or a grass blade. It's got an instance index and a triangle ID which we use to represent the voxel index for a voxel. So this supports up to 64K of voxels per model, and this allows us to support up to 16K instances. So we've got a bit of a problem where currently we have a limit of 16,000 instances which can be given to the renderer, and if you give more, then stuff is just randomly missing. So the solution I've come up with off stream is And this is how it probably works in other renderers as well, right? It's not anything that's probably not a new idea. Let's put it that way. But the idea is the game can give the renderer as much as it wants. It should probably do some kind of culling that it can work out, but it should give the renderer the best it can work out without doing too much work or duplicate work. And then it's the renderer's job to do what it can to reduce the list down even more. So the renderer will get like a bunch of. So I wrote the idea here in the engine discussion on the Discord, and the idea is that the game will probably divide the map into 16 by 16 by 16 chunks or something like that of blocks, and the game will do some simple ABB versus frustum for all the chunks to see which ones it should pass to the renderer, and then it finds all the blocks that are on the surface, so a neighbor which has air. Yeah, so you want to find. You only want to put a block up if it is visible on the surface, basically, and we've got to try and work that out. And those ones we send to the renderer as instances, and then the renderer will basically upload all of those instances to the GPU. It will do a frustum culling on all instances on the GPU and test them against last frame's depth buffer. This is what this hierarchical depth. So, yeah, this is what this whole stream is about, basically the hierarchical Z buffer occlusion culling. So you test against last frame's depth buffer, build a list of stuff that we can render because it's past the last frame's depth buffer. And we build another list of the ones which missed it, which failed to pass that test. So two, ones which passed it, ones which didn't. We render the ones which did pass it, and that will build a new depth buffer. And the instance index here is not going to be the instance of these GPU instances here. Instead, it's going to point to the render list. So this will allow us to say, right, if we cull all the objects before on the GPU, we can then build another list, which is definitely going to be less than 16K. Because if you take the screen that we're trying to render to, like we can ensure basically that there's not going to be 16K instances on the screen. And with that, we should be fine. So as long as the culling is good enough, we shouldn't get any issues. And then we effectively then run over all the failed objects which failed to be rendered, and then check them against the new depth buffer. And the ones that pass, we'll go into the render list and we render those. And this, we make sure we limit this list to 16K, such that if we overflow, such that it never overflows and they can all fit in the visibility buffer, basically. But the fail safe, I guess, would be it will overflow, but we'll get some missing objects. And the idea is that it should only be for one frame. And so when the whole map changes, so maybe when the whole map loads in, you might get a graphical glitch, but we could probably engineer some solution around that issue. But yeah, so this is basically inspired by the classical chunk culling of like a voxel renderer that you typically see going around, but it's also mixed with a two-pass hierarchical Z buffer occlusion culling. So we're going to get started on the latter part of it first, and then the game side will just come in as we do the procedural generation. So yeah, we'll get started with that today. But any questions, feel free to ask away, and we'll get on that. Let's start with a quick prayer, then we'll get going. Father in heaven, we thank you, Lord, for this day. We bless your holy name. Thank you, Lord God, for all that you do, all the things we see and all the things we do not see. Thank you for our lives, our home, the peace in our land. Even though it seems like there's chaos going on in the world right now, where I live and where probably a lot of my viewers live is peace. We thank you for that peace. We thank you for preserving us. We thank you for our families, the fact they're still alive. And I just praise your holy name. Thank you, Lord, for giving us this life. Lord, we pray that you help us overcome any sinful habits that we have, any sinful habits that's causing us, what's leading us to destruction. Lord, take it away. In the mighty name of Jesus, give us a fresh outpouring of your Holy Spirit, Lord, and lead us into paths of righteousness for your name's sake. Thank you, Lord. And Lord, I just pray that you help each and every one of my viewers get to know you. If they don't know you that yet, Lord, lead them, keep drawing them into Jesus Christ, the way, the truth, the life. And Lord, I just pray you help give me your spirit of wisdom, knowledge, counsel, understanding, might, and fear of the Lord, and help me with this project go down the right path and not lead me down any paths of wasted time. Thank you, Lord. In Jesus' name we pray. Amen. Lovely. So, the thing we're going to start off with today is let's make that separate list and let's plumb that through such that the deferred renderer uses that list, right? So, effectively, we'll write up the skeleton code for this system. So there's going to be a function. Now, I should probably bring up the old code base because I've already written this system in a different code base. So I just want to peek at that just to make sure I'm not doing anything too crazy. But if we go to the... By one idea, I should go anyways. Occlusion. Yes, it's prepare occlusion buffer. I called it prepare in this one. Reinit, downsample. Right. This is not a two-pass system. Or is this new one as a two-pass system? That's okay. But we can look at the depth buffer code in that code base. Okay. That's all good. So if we go to so we probably want to have a shader where it's called, right, so shaders, let's find a compute shader. Scene shade's a little big. Graphics in it will probably do okay. Let's just do scene shade, screw it. Right. Oh, no, we don't need to do that one. Let's do graphics in it. So, graphics. So this would be called something like, it's related to the voxels probably. Yeah, so voxel generate render list or something like that, right? So it's the function that we use to go over all of the stuff we need to render and generate either a okay. So I think we'll have to have a separate shader for the second pass. I don't think there's any reuse. But yeah, sort of prepare. Yeah, so the second pass will have to, so the first pass goes over the big instances array. The second pass goes over the fail array or whatever. But the code is probably quite similar. I think we could, yeah, we could probably reuse the same shader actually. Just got to do some, okay, I think I've got some ideas. So voxel render, sorry, voxel cull, voxel model instances cull, something like that. let's just make it a short name, right? Voxel occlusion call. Let's do that. .cs. So that'd be the shader name. So vk voxel occlusion call push constants. And right, so to find these dims, so the dimensions are probably going to be we could maybe it's 256 is good, or maybe 1024, I'm not sure. Let's do 256. Probably a good number. Right, so we want to go to the scene, the shared. So shared will allow us to define some push constants that we can use on both CPU and GPU with some macros basically. Right, so we're going to have a buffer, and the buffer is going to be of those instances. And we probably need access to the slices as well. And I think we just need to know the number of instances. Okay, that we're going over, so we don't overflow. And what else do we need? Yep, this should be it for now. Cool. So the basic idea is we do a PC for push constants. We say if PC. Now I've got to get the right thing because it's always confusing, but you got to get the dispatch index, I think. So the overall index basically. So just got to figure out that one. Yes, it's not group ID. It's not. It's probably GL global invocation ID. That's what I think it is. Yep, this is the one. So it's this dot x. So we could just write it like this way, right? Instance index, okay? Oh. Ta-da! So if the instance index is greater than or equal to this, then we simply just return. Now, we want to do the buffer read only, so just got to find some of that code. Well, it's in scene shade, right? So these are the ones here. And ultimately we need to write into a buffer, and that is going to be, it's going to be this thing called a render list. Right, so you can call it like a render entry or something like that. VK. Yeah, these names are getting really long. These are so long. Voxel render entry. Ugh, very long. Instance to render. It's very long, but there you go. Right, so let's find. I'm just going to put in a structure for now. We're going to use my little encoder system because we can always pack more stuff in there. But the idea is we'll pack in an index, basically, like this. There is going to be some indirection with this implementation, but it's just the way it goes, right? You solve a lot of problems in programming with indirection, unfortunately. So we'll basically link to the instance that we're going to render. Maybe we can pack some other data if it seems useful. But there we go. So we need to make a new buffer type. So we've got some type safety on our buffer IDs. Buffer IDs are basically indices, U32 indices to a descriptor in GPU memory. So we make them type safe by doing this sort of thing here. So yeah, it just defines a bunch of wrap types around an integer. So we'll call it a render to render, or instances to render. We could probably drop this here. And that should be good. Nice. So essentially this will be where the culling will go, right? To do custom call, and then another one will be to do custom call the instance, and then occlusion call against depth map or depth buffer, yeah, depth texture. Okay. So essentially afterwards you just add it into the array, but adding it into an array is too easy and not the most optimized thing to do. So we'll do some little tricks to optimize that because we know how to do it, and you might as well do it the performant way if you know how to do it, right? So what did I call it? Instances to render. And we basically need some kind of, we need some kind of insert index, and then we also need to insert the instance index here, okay? So effectively you're going to have some which don't pass here and some which do. So I guess we can just have some if statements in here to sort of illustrate the point of what's going to go on. And the basic idea you have, you could say, wait, is this what you want? Is this the most optimized way to do it? Am I confused now? Yeah, we need to get an insert index. So the simplest way would just be insert index equal atomic add. I think you have this function in GLSL. Let's find out. GLSL atomic add. Yes, so it's atomic add. Now we need something somewhere. So we can put it in the globals and we'll call it instances to render count, right? And we're going to add 1 to that. So let's go to the globals. You don't have a line as in this, which kind of sucks, but there we go. Shading programming languages for you. Voxel model instances to render count. And every time we start a frame, so in graphics frame init, we've got this guy, which is amazing. We can clear it to 0. Ta-da. Cool. So this would be the simple way, and it would be okay, but it's not as good. So what the problem is you're running in lockstep with a bunch of other SIMD lanes, right? And each and every one of them is trying to access the same global variable and be like, hey, atomic add, right? Not a good idea. So what you should do is use wave intrinsics to basically say how many are here. So there's there is one of these, good. So how you do a subtraction is you do the negative int. But anyway, right. So what about a wave prefix sum and wave sum? Got to find those ones in GLS. So just give me the functions, please. Thank you. Subgroup. That's it. Crying out loud, these are so dumb. I'll probably do this silly thing as well. But I think they're already in a header somewhere. Anyways, so this will only add on active lanes. So all the ones which have returned, right? So this will give us how many we want to add. And then this will give us our sort of relative offset, our relative index with the prefix sum. So a prefix sum is basically saying, so you got a bunch of lanes, right, up to 32 lanes that run in lockstep. Each lane in order will get a 0, 1, 2, or 3, depending on which one it was when it added 1, if you get what I mean. And whereas in this one, all of the lanes will get the total number. So say if there's 4 active lanes, each and every one of them will get 4. Right? That are still active. Okay. So with this trick, we can now say, right, if I'm the first lane, so wave is first lane. How'd you do that? Why did you give me HLSL when I asked you for GLSL? Well, I guess I used GLSL speak here. But still, I was talking about GLSL above. Crazy. Anyway, so we're talking about now wave is first lane in GLSL. It's going to give me another essay. Anyways. So we need... elect. Right. Why did it make it so complicated? So why this works? Only true. Anyway, I guess it's still better trying to find it through than the GLSL documentation, right? But still, it could be way better. Like if you try and find this through GLSL, you got to find the extension and then scan through all the stuff. And it's annoying. You're best to download the GLSL GitHub and find it, but it's long. All right, so if elect, right, so this gets the lowest thread index, which is active, and now you do your atomic add in here, right? And then you add the total count, and then you can initialize this to U32 max, yeah, and then you just do a wave active min, or a subgroup min, I think it's called. Right, so it can do subgroup broadcast first. Right, how does subgroup min verse compare? Because I usually it's just do subgroup min. Selects the data based on lane index position. Right, okay, that might be better. But this requires ballot, right? Fair play. We'll just do this then. So, right, okay. So insert index equal. So this will get this insert index, which was on the first lane, to the rest of the lanes which are active. Right, and then finally you can basically get rid of that. And so this would be a base index. So base insert index plus relative index. And there you go. So that's the quicker way to do it. So the other way you could do it is by doing thread local storage, whatever it's called, LDS or thread group memory, that's the other word for it, and share it between your 256 lanes. But then the problem is you'll make a bunch of lanes go idle, a bunch of different compute units go idle. Well, they can swap up to 10 at a time, but yeah, you have to park them to be inactive and they could take up, yeah, so you'll just have to do some perf tests with that, right? But it should be fine. This is the easier way to do it. I could just say to do check to see if doing a if doing a single atomic add over the whole thread group. Cool. Right, so this is a good foundation to go. Now we're gonna go CPU side and try and hook this all up and oh, we forgot something. We need to say, right, here we go. So if insert index is greater than the graphics voxel model instances to render capacity, then we need to break, right? Or we shouldn't insert this one into the list because it's going to overflow if not. Okay, cool. So what else do we need to do is put that into graphics shared. Okay. Cool. So yeah, we could probably swap to a lot more, but let's just leave it at that for now. So the idea is to go to internal now and make a new buffer. So go to the voxel cache So, well, fine. Model instances to render buffer. Okay. Yeah, it's not really part of the cache, you see. Oh well. Right, let's get the code generated at least. Cool. Right, where's the next step? So we want to find all the cases of this and see what's going on. So yeah, this has a capacity here on like 16,000, 16K. It's no longer a thing. But instead though, we should put some kind of, what do we do? Yeah, we want to put some kind of assert on, it says that GPU triangle, sorry, graphics triangle VK triangle ref, this thing. So what I want to do is sort of debug assert that there's enough. That this capacity, so graphics VK triangle instance set. If you can write in capacity take 1 and read that back, then there's two things we want to check, right? So you get it. If it still equals so we can say visibility buffer, VB and LB buffer can no longer, so we can say that it's can no longer fit or cannot store of this number. That's a problem, right? It doesn't have enough bits. Doesn't have enough bits to store take 1, yeah? Lovely. So the other test as well is like you have too many bits, right? So how do we test that? So if you pack plus, so the other one is if you pack +1 and then you get it out and it is not equal to, yeah, it's got to not be equal to that. Right, so now we can say it's got too many bits. Oh, no. Why am I saying +1? That's a difference of 2. It's incredibly dumb of me. All right, here we go. So has more bits than is needed to store this. Lovely. Look at that. Well, that's a good check. So this way it keeps us, you know, we don't accidentally change the visibility buffer, packing code, or we don't accidentally change the model instances code and then they come out of sync and then, you know, so this is great. Cool. What's the next thing to do? So look for these model instances. So upload goes into here, right? Now, the voxel render visibility, this should be taking in, well, it should be a few things, right? It should actually be a deferred, what's the way of saying it? It should actually be a indirect call, right? And yeah, there's a couple of things. So we need these guys in here, instances to render. Cool. So we need those, and we need to make it indirect. So where's the indirect stuff? Here we go. To draw indirect. Yeah, I think these are just plain draws. I think. Yeah, they're a plain draw. So we need an indirect for voxel render, visibility, VB. We need another one for the layer buffer. That's the order independent transparency pass. And where else do we need another one? And for the wireframes. So the wireframe could probably just be done last anyway. Yeah, it can. Good. Oh, wait a minute. The layer buffer doesn't need. That's doing transparency. It won't be doing the two-pass occlusion. So we'll skip that one for now. Okay. Very good. So we need another compute shader, which will basically take those values from the. Have I got them called prepare in the past or setup? Yeah, they're called setup, these guys, which basically set up the indirect arguments in a small little pass, basically. So where's the grass setup one? There we go. We'll call it voxel render VB setup. Okay? And the wireframe needs the same thing. I'll get to that in a bit. Voxel render VB setup. Yeah, so right, it's just a box, so it's 15 vertices, I think. By the way, or is it 24? No, it's 14. Oh yeah, sorry, it was 15 for the grass because of that thing. Yeah, 14. Then shared. Right, so it's the to render. This is our boy right here in the globals array, in the global structure. So it does a buffer basically, is all it does. Yeah, it reads from a buffer basically. And the I reads from it writes to another buffer, right? Then yeah, I wonder how the I one works actually. Graphic GPU is in graphic shader then. Yeah, there they are. Oh, okay. Yeah, just access it via the descriptor array basically. Hard coded. Right, that's why it works. Nice. Rightio, so yeah, we're just gonna make sure we sync on the right places basically with these. Okay, super cool. So the other one would be the wireframe mode. One, basically the same. Cool. So let's make the changes to the CPU side code. Oh, yeah. Hang on. Shader. No, shared, isn't it? Yeah. Layer buffer. Yeah, no changes there. Right, let's leave that alone then. Okay, so render opaque voxels. We need to do a setup pass. So let's find the word setup. Here's one. So we need to make a new compute pipeline or a couple. Voxel render VB wireframe. Cool. So those will be set up automatically. It basically just, loads from the file and creates the pipeline and all that as part of some multi-threaded system and all of that. Very cool. So that goes there. And we make sure we sync to the global buffer because it reads from the global buffer, right? And that's a good point. Shouldn't it be also be syncing right only to the indirect? It should. Yeah, we're not been syncing correctly on that. Let's sort that out. Yeah, it should be syncing right, read write maybe, or write only is probably fine. Yeah, on indirect. Right, so shared. Indirect args. Right, very nice. Cool, so we actually want to take that and find the other setups and just dot them in there as well. Because they're actually missing that. Nice. Right, let's look at that draw 3D setup quickly. Yeah, they are just storing, so they can be right-handed. They're not plus equaling and doing a read write. Cool. So there's the setup thing being called in the right place. So to make them indirect, we do have to the problem with sync code sometimes. Anywho, so let's go back to the opaque. All right, so down here. So we throw that in. Indirect read, yeah. And I've got to change that. Voxel render VB, yes. Voxel render. Right, we're in a good place there. So we need to use the indirect spec. Which is a bit different. So it just has an arg offset. So that'll be voxel render VB. Oh, why is it ending in render? That's not very nice. Very dumb. There we go. And then we instead do indirect draw. Yeah. Ta-da. So we'll do the same thing for the wireframe mode down below. The only issue cool. Yeah, so now we've got to get the setup one up here. So it's this one here. Right, so that should be excellent. So that's now it's using indirect. So the thing we've got to remember is we've actually got to pass in another array. And this is going to be the instances to render array. So it's the indirection, right? After the occlusion. And that'll be to render. And you got to use the to render. Okay. So down in the wireframe we'll do the same thing. Are you telling me it's been wrong the whole time? Why is the wireframe? Yeah, right. Let's rework the wireframe a bit to be doing the right thing. It's using the layer buffer shaders, but not the visibility buffer one. Because it was built using the order independent transparency at first. But it's no biggie, just a quick change. Just write VB instead of LB basically. And then go to the wireframe shader and get it to use the right push constants, which it's not really using anyway. But yeah. Right, that should be it. Cool. Right, so what's the next thing we can do? So inside the visibility buffer render, we don't do instance index in the instances array anymore. There has to be indirection. So you got to get instance index is actually, as we just said, indirect, right? So this would be a to render, and we can just call it R, I guess. And we'll read this full thing out. It's just a wrap to U32 basically at the moment. And so we're just doing r.instance index, yeah? Voila. So it's the same thing. Potentially in, I think we need to do another out variable now. So we can read it inside the pixel shader. So essentially we'll just define that up here. Voxel VB fragment. So that's now an in, and instance ref. Or where do we do it? Oh, it's here. Oh, but it got it from the instance reference. Oh, that's a valid point. Yes, so this one is the packed one. So it's doing the packing straight away from here. Right, I see. Yeah, so this has to be that one. And right, so we don't read that out. It'll be an I instance index. Cool. Very nice. Right, so that's gonna be the right numbers, right ones there. I think though the wireframe will need to declare this as well. Because if not, the pipeline creation might complain. Cool. Right, we're in a good place there. Yeah, so that should be the visibility buffer using the indirect list for now. Oh, I completely messed that up. Okay, cool. All right, anything else that we need to do? Not here. Okay, so now we need to change it inside scene shade, right? So scene shade is the deferred rendering. Yeah, I don't think it has to be inside merge visibility buffer to layer buffer, does it? That doesn't touch the instances, which is great. It's purely pixel data. So scene shade. This goes over the 4 layers and, you know, shades them, right? Just 4 layers of shading, or up to 4 layers. So in here there will be a place where we get the instance data again. So we want to plop that in here. Use the instance index there, then do r.instance index to get the instances, yeah? Now, lovely. Right, so that sorts out that one. So we do indirect there properly now. So from the CPU side, we do want to correct scene shade. So it is here, and I think we already defined it. We didn't, unfortunately, so we've just got to do that quick. Put this here, so it'd be known as the voxel model. It says to render. Now, part of the issue is this might be too big. We'll see though. See. We might have to pack some of these buffers down into, I don't know. The push constant structure is unfortunately going to overflow at some point. There's just so many resources coming in. Maybe we should just throw it into a buffer somewhere and sort out that way. I don't know. But yeah, so many buffers. Or maybe we can make them constant. So we don't have to keep passing them in everywhere. We'll see. Anywho. Cool. Read only. Very nice. Cool, so that should be scene shade is now adjusted, right? So is there anything else we need to do? So the occlusion culling code needs to be called still, so we missed doing that. So yeah, we haven't really got proper occlusion culling yet. We're just getting the basis for it in. So effectively, we're going to do render to opaque voxels. We would probably want to do, yeah, let's do like occlusion. Yeah, so there'll be like an occlusion system basically, an opaque for opaque renders. Meshes, we'll just avoid that for now, but they'll all join the same system at some point. There'll be occlusion call it something like that. And it will be broken down into multiple passes, right? But we'll progressively get there. So there's a shader called a voxel occlusion call. So right, occlusion call voxels. Let's do that, okay? So get rid of the word render. Okay. So we want to launch a compute shader. Let's find a compute shader which is not a very simple one. This ought to be good enough. So the idea is we do that voxel. Right, pony, that's it. Good. And we find all these guys. So we want these slices and so these need to be read right or right only. Maybe you can probably get away with that, right only. Okay, so it's right only. Then the number of instances is cache, voxel cache. Well, Yeah, where do we get those model instances? So that's in wireframe that we do it here, don't we? No. This is it here. Okay. And that is it, apparently. Now we dispatch the voxel occlusion call, that's it. And the x dimensions are PC instances count divided by 256, rounded up, and 1 along the y, and voila. So that will just launch. Nice. So that will at least set everything up properly such that this instance to render, or instances to render array gets populated with the instance indices, and we can fill in these culling, frustum culling and the depth buffer occlusion culling stuff as we go, right? So here we should be at a good point to try and run it. Does it work? Does it not? And we'll find out. Here we go. Right, got some big issues apparently. So I see. So the setup guys, those underscore renders at the end, we accidentally copied those in, even though they made no sense. Didn't look until later and found it was silly, so I removed it, but I didn't update these. Right, let's keep going. So this requires this extension here. We're just going to add it. Everything's an extension. So it's added to every single shader because yes. Cool. So occlusion call has a problem. It doesn't like this for some reason. Oh, because we're meant to say, right, okay, I see. So we're meant to say instance to render, and then we're meant to like ta-da. Boom. And as you can see, nothing has basically changed, which is what we want. It looks the same as it did before. So now, if we check the profiler, what we see is as follows. We see a voxel occlusion call, right? Followed by a voxel render VB setup. And now it does this in an indirect way, right? And then, yeah, we could try out the wireframe mode. Right, wireframe mode is broken. I think it's before Bloom, isn't it? No. Oh, VB setup. Ah, that's why it's doing VB setup and not. Right, I see the problem. No biggie. So that is in... Right, I'll sort this one out. So wireframe, copy paste. We need to do the wireframe setup shader. Okay, so if we press F1 for wireframe now, it should work. Ta-da! Ta-da! Cool. Okay, so what is next? So now we have the indirect list working, so we will basically never fill up this array anymore because it has this capacity. So the GPU can be given as many instances as we'd like, and now it's our job to actually cull it, right? Cull stuff from the list. Yeah. But we're not doing the two-pass system yet either. We're not putting stuff in a good list and a bad list. So there's that. Yes, I think what we want to do first is get the frustum culling, the depth buffer occlusion cull from the previous frame. We want to get that code in first, and then we can do the two-pass system, I think. Yeah, that'll be the way to go, I think. Cool. Right, I'm just gonna take a quick break, get another drink, but any questions, feel free to ask away. BRB. Right, welcome back, everybody. You're doing good. So we're going to try and do some frustum culling code now, and then some occlusion culling against a depth buffer. So we kind of want to, know does this work? Is this something we could do which allows us, you know what, let's write the code in first, and then we'll write the debug thing, because that would be pretty cool. Yeah, so, right. Basically, you need to code against the frustum planes of, right, so let's have a look. What we got here. So the instance will give us the matrix, and we need yeah, so I've got the wall from local here, and I wonder what else we can do. Let's see if we get some little help. So GLSL, frustum col refrain, frustum col, I guess it's an OBB in it. OBB with world from local matrix, something like that. Yeah, this is going over all 6 planes though. I'm sure there's a better way of doing it. How to extract planes, that's pretty cool. The view projection matrix. Okay, so is there a better way, more optimized way? Let's see if we just get something. Is Tomato doing with subgroup stuff? Is that because I've... Hang on. Mask subgroup reduction fastest. Transform to combine local space. Transform in all 6 planes from world to local independently on every thread. You can use subgroup operations to cache. Right. There's cache, and then they're avoiding repeated memory fetches. I'm not sure if that's realistic. Maybe, it just depends. Not sure if that's realistic, not gonna lie. Right, so the bit that I'm curious is there, because there's 6 planes, right? Is there a way to test against less planes. I'm pretty sure, because there's that trick when you do a because when you have like an ABB, you can basically do half the number of planes, right? I wonder if it's similar. It's a different shape though, isn't it? So skipping specific planes or conditionally reducing the plane checks based on camera configuration and layout. So drop the far plane, 5-plane test. So that's on an infinite Z, we don't have that. Drop the near and far planes for distance. Right. This technique determines which direction the camera is facing to the object. The bounding box can only ever fail a frustum check on its if that's actually moving towards or away from. Ah. Yeah, but then that's an interesting trick. I've been thinking about that in a similar way to rendering boxes in a way, but okay. Okay, let's go back to the first set of code and start looking at that and break it into some sort of reusable thing in the engine, right? So this one here, so for the view projection matrix, I wonder how that works. So let's go to my shared. So render visibility buffer VS. Yeah, so I calculate the projection from view with this guy, yeah. So this is my, I calculate that on the fly. Okay, so I wonder if we can get the frustum planes using that. So oh, did I do the wrong one? Damn it. Planes using this guy. Let's have a quick little look. This thing has been so trashed. Okay, so let's see how good this one is. Did I paste the right thing? I did. Exactly, cool. Right, so it says based on your engine uses the Vulcan style, yep. Yeah, yep. because your projection is built differently, sorry, specifically for Vulkan clip space, using the standard OpenGL1 will break it exactly. Oh, wait. My near is not 0. I'm pretty sure it's in reverse Z, isn't it? I'm pretty sure I did reverse Z. Pretty sure. Right, okay. I swear I invested in time to do that. Maybe I didn't. Okay, that's fine. Right, so let's take a look at this. So we've got... Right, so at some point, we need to calculate these. The projection flips the signs of axis during the perspective divide. Okay. So where are we sticking these planes? So they're a bunch of vector 4s, aren't they? Basically. So we can call it... Right, where can we stick this thing? So this is in shader. So as part of GPU in it, we could... Okay. So these planes, we want to stick them in the global structure. So we can just call it like... Custom planes. Nice. So we'll have this just stored. I think there's graphics in it. Wait, persistent between frames. We want this here. And so in graphics in it, that shader, we'll have this function, which will do all of this. So it extracts the column vectors. So your matrix is going to be map4 projection from view, and that will be count projection from view. It's a lovely little function we got, which just calculates it from scratch. Can't find it anymore. Right, projection from view calc. So in graphics in it, So extract the column vectors. Okay. Then linear combination of the planes adjusted specifically for, right, so it's the left plane. Yeah, so it seems like to me this is not the way to do it. We should make a structure instead. So we'll call that frustum. Frustum planes or something like that. Yep. So we'll have left, right, bottom, top. Yeah, I guess this allows you to just do indices and do for loops, right? But then you can just always inline the code anyway. It's not the end of the world, right? But yeah, so it's doing that. And then later on, there's this sort of subgroup optimization or whatever. That's why I called it that, to be honest. I don't see any subgroup intrinsics. There's no ballot at all. Anyway. Okay, so maybe we should just do yeah, let's just do yes, I think the reason why I didn't do a reverse Z is because my stuff's going to be quite near to the camera anyway, I think. I think so, that's why. Anyway, we can always do it later. Yeah, so and near far basically. Yeah, maybe we should do that as an enum. Because I'm thinking maybe debug drawing these. Cool. 2, 3, 4, 5, and 6. Lovely. So calculate frustum planes. Right, so you've got your, I guess we can just put this in here. So it'd be left, right. You know, it'll be easier just to do this. And we want to store those in a little local. Okay, so we can just do an out planes. Maybe. Yeah. So just specifically. Okay. So cool. So at the end we basically just want to write into the planes. So it's these guys here. Do a 4 range over there. Index 0. Oh, no. So it's the planes. So we want to do that sort of conversion. Code, I think that's it. Yep. Of planes. Index. Cool. Right, so that should set everything up. Those planes in the global variables. So now all we need is a function inside shared, which will basically allow us to frustum cull. Now, or shader, mind you. But it'll make it harder to compile everything else though, wouldn't it? So what is something we should do? Right. Right, so cache them avoids cool. So we want to put this into a function basically. I'm not sure what this is talking about because it will probably write an OBB and a world from local. Where's the box? C3. Oh, so okay, so it transforms the planes into the right, so that's not really an OBB then. That's an AABB. Right, so transform the planes into the local space of the the object. Okay, gotcha. With this by calculating dot products. Project the local half extents onto the local plane normal. So expect 6 planes extracted from your... What I don't get that that's missing the view from world transform. When you extract the Froston planes from your combined matrix, view projection, right. I see, so it has to be a view projection. Right, okay. So in that case, so in shared, there's the globals, view from world right here. So we have to turn this into a matrix basically. And this gets calculated, it's uploaded every frame. So in frame in it rather than graphics in it. I want to take this and put it into shared. The Frost and Plane thing. Cool. So here, we need to get there's a matrix 3D. View from world. WG view from world. Oh no, sorry, wrong way around. I meant, wait, no, that's right, view from world. So we need to somehow combine these two. The issue is this type is actually a combined, sorry, it's a simplified version of a matrix, isn't it? So it's got to find, how do we map this? Where is it at? Yeah. Yeah, so it's a 3x4 column major with an explicit fourth row. So right, so let's ask GLSL get the axis vectors. Right, so it is just .xyz. Okay, good. So then it's just the W column. Right. So all we need to do is turn this into matrix 4. So it should be m0.xyz equal vec3 underscore o dot axes 0. Now you've got that a few times. Then you got translation. Cool. So the final thing is you want to set W to 0, 0, 1. Think. Yeah. So now the final thing is .w. And there you go, return M. Cool, so now we can just do this. Now it's this multiplied that, which makes it a view from world. Sorry, projection from world. There you go. Cool, so now we just need to make that function in, we could probably put it in shared because it's going to be reused. Shader I meant to say. But yeah, this is included in everything, single shader basically, so there's not really stuff in sections yet, so we can just dump it. Well, there kind of is. But here we go. So there's this one here. Right, so the box is worthless, basically, to come in, because local space is local space. So we want to say is OBB in Frustum, and we're just going to use a unit box. So this will be a matrix 3D. Right, so it's a plane, so it will be right, interesting. Yeah, so let's see. So world from local. Now we could turn that into a matrix or whatever, but we could equally just do this. So this would be dot axis then dot translation. So this would just be turn that into vector 3 from our sort of packed type to this sort of unpacked type. Yeah, so my vector 3 has like scalar alignment, whereas this is vector alignment. So then we want to do a vector 4 with an implicit, where we explicitly put in the last one, so 0, 0, 0, and then 1 on translation. So it's saying that we should cache these. Yeah, I guess so. But the compiler should sort that out, but it's a good place to stick it there. Hey there, Buzztronic, welcome. Yeah, you should give it a go. It's Helix is great because you know the config file is really simple. Like mine's only a couple of pages, 100 lines, because I use the Comac keyboard layout, and that's basically the whole thing, right? It's different shortcut keys. But you don't have to do all that. You know, I made my white space characters these things, but you know, it's quite simple. Oh, you can't hack it with Lua, right? Yeah, maybe. Don't they have? Yeah, I'm not sure if they have extensions yet. Maybe they don't. Man, I ran out of drink already. Frost and Plains. I'll put Frostem. Epic fail. Frame in it. Right, so you get the Frost and Plains from G. So convert that into vector 4 from our sort of scalar packed type. Is there a hotkey to toggle a terminal? I'm not sure actually. I don't know if it has one. You have to look online. I don't know if it does. Right, transform world space to local space. This is the world plane. Local plane. And then normal and distance. Project the half extents. So the local extents, this is a constant, right? So half dims of local space is 1, I think. Yep. So that's the scale basically, yeah? So that's basically just, yeah, you can sort that out. So project onto the normal, onto the plane of the normal, right. ABS trick finds the absolute maximum projected radius. Okay, the AB along this axis, right. Cool. Compute sine distance from the OBB center, so that's just another 0 again. Well, constant, I meant to say another constant. So 0, hang on a minute. Yeah, so a dot is just going to be doing a bunch of like, yeah, that's not right. So maybe we don't need the normal then. No, we don't need, it's just distance. So that would be, yeah, because dot is just multiplying and the sum, isn't it? So that's not even needed. If Volts is completely behind any single plane, it is out. Cool. Right, let's call that a, there we go. So we have this thing now. So we should be able to, in the occlusion call, simply just say, right, just instance dot world from local. Yeah, I wonder if that is the right way around though. Oh yeah, it's the transpose, isn't it? No, not the transpose, it's the inverse, I meant to say. What was it saying about it? Hmm. For this. Yeah, that's, I don't think it's a compiler extension, it's just a hint. But the thing is from my knowledge is that shader compilers always, they absolutely always inline stuff when they can. Sorry, on a roll. They always inline, but that's an always. But they basically always unroll when they can when it's a constant, right? And the way you get it to not unroll is you just don't do that. But this, yeah, this hint just ensures that It's the same across every single compiler vendor. Yeah, I think this is correct syntax. It's definitely like that in HLSL. There is other ones as well you can do. I think it... Right, so it takes the world from local because the function performs a mathematical shortcut. It transforms a 4D plane equation backwards from world to local space. You must multiply the plane by the transpose of the matrix that transforms positions forward, which would be transpose or from local. However, GLSL handles matrix multiplication using column major rules by manually using dot products against... Right, okay. Cool, interesting. All right, good to know. So that should work. So if it's not in the frustum, return. Yeah. So all we need to do is write some code which will allow us to debug this sort of like, to debug this occlusion culling, right? We want to have a way to turn it off and turn it back on and kind of, well, we probably, a way to like freeze where the camera is and sort of visualize like the camera basically with the frustum planes and kind of debug draw those. I think that'd be a good idea. And then we can see like what stuff is being called and not being called. And then we can do the occlusion culling against the depth texture. This is a good first start. So let's see if this will work. Just going to take a quick break and get a drink. Right, welcome back. Welcome. So, if we try and run this now, what happens? Compile errors. Boom, boom, boom. So it seems like this unroll thing requires like a control flow attributes thing. Or something like that. I think that's what it's complaining about. Yeah, so these like extensions and stuff, right? Cool. We'll chuck this in. Okay, so I want to put that in GPU VK add, I think. Right there. Lovely. And it's also complaining about shader. Which one are you talking about? 238? Oh, okay. Right, so let's try this out. Cool, so what we've done is we've seen it culling now, the wrong pieces. It seems this is off here a bit. Now, when I was looking at the code, it was telling us that it might be wrong. It was telling us that here. So, because of my matrix, this one is positive. Your projection flips the sign of the z-axis during the perspective divide. Your z view direction points down the positive z in view space. Yes, that's correct. If your scene geometry or camera tracking feels inverted. Right. Yeah, it feels inverted to me. Okay, so effectively we need to go to frame init and negate that and plus that. No. Bum bum bum. Right, so what could possibly be wrong in this? You know, I wonder if it's... That looks fine to me. Hmm. Right, I see how that's sort of working. So it's saying like your translation plus sort of the right vector, translation minus the right vector. Right. Yes, so maybe these can flip the other way around. No. Yeah, maybe it's the near. No, the near file must be fine. Yeah, I wonder why that. Oh, the whole reload's not working. That's why. It busted. Right, so let's flip that the other way around. No. Right, so I think maybe this plain stuff could be correct. No, it seems like the near and far is the other way around, right? Is that right? No, it's something else. Right, maybe this is okay. Yeah, I feel like it's like a transform thing that's a bit off. Um, hmm. Or is it 0, 1, 2, 3, 4, 5? Yep. Yeah, that's the right way around. So, right, so we did that thing where it said do that. Then yeah, it would be great if we can probably debug draw this, right? Freeze the camera, debug draw. Maybe that can help us isolate the problem, really. So how can we manage that? We've got debug drawing already. We've got GPU VK shared, I think. There is like draw 3D. Oh no, graphics VK. Shader, I think. Yeah, we've got them in here. So we've got ways of, I think, drawing a plane or something. But I don't think it's position and normal, basically, right? So, and we do the half dims. This will be useful. Yeah, so given the frustum planes, what will be the best way to render the planes using this world space function? See if it's got any ideas. Because I think it will be right, it's way too much, isn't it? No, okay, I see. So it's saying right, so you can get the corners and stuff. So to render your frosted planes using that function, you need to extract positions for each plane. Yes, you want to get the corners of the frosting basically, I see, right? Yeah. So, and then we can have a way to sort of like freeze the matrix and then move the camera around, and then we should be able to see it. There is a color, so I think we could get it to blend. I think we could. Although I'm not sure. Draw 3D. I don't think we can, you know. Maybe we can. Yeah, we don't want to use that function anyway. We actually want to draw lines. And yeah, we actually want to draw some lines. So we do have vectors, although vectors kind of suck because they have a yeah, vectors kind of suck. I think we want to add another debug draw, a line, and then yeah, if we do it with lines, then we can just do the corners basically and do a thickness. So yeah, let's add a line debug draw, and then we'll so you want two positions, start pause, end pause, some kind of thickness. So cool. And effectively you want that in every single place there is. So there's a few places where these are, which kind of sucks. Why not switch to Linux? Yeah, well, he's wanting the same thing. That's cool. Basically, guys, let me let you guys in on a little secret. I was using Linux before Windows. Bwom, bwom, bum. And I've been using it for a long time. Over half my life. Since I was like 14. I was using Linux. But I switched to Wayland. And unfortunately, Wayland didn't work with RenderDoc. And I was like, ah. And it really just threw a wrench in the gears because I needed RenderDoc to do GPU programming. And that means I would have had to have maintained X11 and Windows and Wayland. And I was like, ah. There's too much code to maintain at the moment. So for now, we're just doing it on Windows. That way we keep it to one platform. Yeah, it's a shame. They require an extension for absolutely everything. It's like, oh, you want, yeah, you want to do anything in Wayland, it requires an extension. Is there a reason why using Google's AI instead of CP and local models? I'm just using it because I'm lazy and it's just there. I don't really use AI too much. I only use it when I want to Google search for stuff, basically. And today I'm just happening to use it a fair bit, but I don't usually use it too much. Only for when I Google. Because basically Google made Google search terrible over the years. I remember when I was younger, I used to be able to use Google search and find the stuff I wanted. But now you can't. It's a right pain in the butt. But this AI thing has come along and it's kind of helped find the stuff you want. So that's what I use. But yeah. So that's kind of cool. Right, draw 3D. It's repeated in like a bunch of places. So basically you can issue these debug drawing stuff from the game thread, from the graphics thread, from the GPU, and it will just show up on the screen, basically. And that's the reason why it's implemented in like a few different places, because we support doing it from a few different places, and it's very powerful and awesome. So we have to deal with this when we want to add a new thing. So this is the CPU side stuff. There's convenience functions in game.h, I think. Here they are. Let's do this one. So when we're working on the game, we can just easily call this. Then there's one on the graphics side of things too. Sorry, graphics Vulkan. But yeah, I would like to use Linux. It is something I've been using for a long time. So if I did anything server, I'd obviously use Linux. You know, it would be great in the future when this engine is in a good place and the renderer is in a good place, like maybe just to get the platform layer working again for Linux and probably develop over there. But I'm not having a bad time over on Windows, to be fair. And, you know, we have rad debugger over here, which you don't get on Linux. So, yeah. But yeah, I know rad debugger's been ported over. Soon, TM. Cool. So I think that's all this places. Now we just got to change the draw 3D. What am I working on? I'm trying to get the frustum culling working. So we're just currently writing some debug code to try and get frustum culling. To try and see what's going on wrong with the frustum culling. So we're gonna draw the frustum in world space and see if that can help us solve the problem. But also, it's going to help us debug occlusion culling as well. So this is not just to check the frustum culling code to see what the problem is, but mainly just to see like all of the occlusion culling code does, if I freeze the camera in a certain space, I'll be able to see the planes of the frustum and then see like, hey, these objects, you know, are the objects that are outside the frustum cold, right? And if not, why is that? So we should be able to see the frustum culling working. That's the plan on what we're trying to build. And then we'll be doing the 2-pass hierarchical Z buffer occlusion culling. Okay, so I could produce something called vec. So we did end take start, then half it, or yeah, so effectively what you want is start pause plus end pause divided by 2. That's what you want. But then yeah, you just gotta hope the world. Anyway, that should be alright. Then it's a mid pause plus. Yeah. So this will basically draw, this is the vertex shader, so it's drawing an oriented bounding box around a line. That's what it's trying to do. Sorry. It's trying to draw an axis line bounding box around a line, I think. And then inside the fragment shader, the pos vex even end. So it's just a shorter version of this. The vector code is going to try and put a cap. So effectively we're inside every single pixel inside that box is now going to ray trace against a few things. And I recently switched to macOS because of the power efficiency. Awesome. But I did miss Cache OS system. I've not heard of that one. If I wasn't off grid, I wouldn't worry, but the M line is amazingly power efficient. Yeah. See, I heard they've also got some like Windows laptops which sort of do similar these days as well. Yeah, I was considering looking at getting another laptop at some point because my one here constantly requires the charger. It's an old Lenovo ThinkPad, but yeah, I need to think about that. No, I'm just using Helix editor. Effectively, right? It is what you expected NeoVim to be, right? Ditch the programming language config file and just have a config file, and it's amazing. And it comes built in with all the stuff you want. You don't have to maintain all these extensions and stuff, and you know, just get the job done. Right, so I think you can just do end pause. End pause, I guess we could. Right, so the cone. There is no cone on the end. I think we just need the vector. So verse capsule. I guess it's just a capsule then, isn't it? But that's fine. Vector cone length. So we don't get rid of all this cone length stuff. No cone thickness. Capsule start is position plus vector and thickness. Yes, that's right. So we'll call this capsule end. Alright, that should be it. Okay, so how do we need to get a vector, so vec3 vec equal end pause take start pause. Yeah, I think that's all right. Right, so that should be everything to draw a line. We can test it out quite easily. If we run the game, we can oh, come on. We haven't declared the enum. No biggie. But what we can do is just find a shader, call the function, just double check it works. Draw 3D. Oh, it's in the vec shader. The half vec. I see, we do need a half vector. Yeah, what we should probably produce is vec, which is end take start. The position is equal to start position. Cool. All right, we're back in business. So we just want to find a shader. So we can probably do it from frame in it, I think. I think we could do it in where we simply do draw 3D line. I put in a world space position. So we can do vec3, let's say 0, right, -1. We'll put it up in the air a bit by about 3. And we'll do 0 along the Z. And we'll do the end position just being a +1. Then I think it's thickness and then a color. Thickness, color, Z test. So thickness would be, let's just say 0.2. Color would be RGBA 8 white, which I guess can be -1. And then we just do false for Z testing. Let's try that. Cool. So what we're drawing is unfortunately a line. Sorry, a vector. Because we didn't change the enum. And I'm kind of confused why. Is it drawing it up? Oh, that's because it's the second parameter is a vector going up. Yeah, that's fine. That's the vector one. Right. So we actually want to change this to Right, so that those types in draw shared. Let's search for all these. There's a double. Yeah, so this should be line here. This should be line. Cool. So we try that out now. It should be drawing some lines. Oh, a line. There it is. Bum, bum, bum. The capsule. So there we go. It's called a line. Wait a minute. Have we already got... Yeah, we don't already have capsule actually. So maybe we should just call it capsule. Yeah, we should probably call it capsule, but there we go. But I think line is more natural. But capsule is what it is. But yeah, so what we need to do now is basically effectively shader. Right, so how about with this? See if it picks it up, that'd be fun. Is much easier and cleaner because you just get the corners, right? Yeah, see the NDC corners. So you can get the wall space corners of the frustum. And then we can just do some draw lines basically. That would be quite cool. Cool. Let's see if we can give that a go. So going back to frame in it, I reckon we can just drop this in here. So we can call this void debug draw frustum. So we want to get the view projection. So it's just this guy. Once you break the seal and start paying 20 a month for LLM coding, coding harness stuff, you'll never go back to the chatbot. Okay. You're so lazy now. Yeah, that's the issue of it, isn't it? Yeah. So this is why I limit myself to only using it when basically it's gonna completely fry my brain and go outside of my understanding. You know, I try to program as much as possible. Yeah, it's only when I'll just be. The rule is if I'm going to web search for it anyway, just use the chatbot. But yeah. Yeah, what sort of stuff are you building right now? using the AI? And is it like completely like doing your project now in ways? See, this is the issue. They're going to get you with that. They'll make you like, they'll up the cost. You know, yeah. But you know, this thing starts becoming free. It's just like, okay, probably just won't use it and go back to searching the web again. Game engine like you, yes. I've done everything myself, but basically telling what I want. Cool. It plumbs through the whole massive code base. Awesome. Yeah, exactly. Yeah, you can't feel very secure about it. um, but it changes how your mind works. You know, it's. I guess we'll leave that there. Person can't see binary subscription servers. Yep. I just spend time tweaking local models. It's quite a bit of time to get right. Oh, okay. Yeah, but the issue is though is deferring your thinking to these things is a problem, right? We need to be able to think and process problems, because if not, we just defer to machine. You know, that's an issue. That might help that it's a well-established code base, not from scratch. Another. Oh, okay. Nice. As soon as we start thinking for you, it became our civilization. Yeah, see, this is the problem, right? The end game is man put computer in brain, right? And you know, and also man is also trying to put brain in computer at the same time. But yeah, this is the end game for the robots and the Antichrist. Right, the Antichrist wants to make his unholy spirit, right? Not the Holy Spirit, the unholy spirit, and that'd be probably be the mark of the beast. And people be like, "Oh, I can't do my life without merging with a robot." But yeah, it will come someday. Until then, we just keep spreading the gospel. Right, so obviously world corners, supposedly it's just something like this. So wait. So you're doing your, oh, I see, right. So you're from end, yes, you're doing the inverse, right? Cool. Nice. Lovely. So we simply just, that's a good idea, put that into a local, ought to be good enough. Jam that in there. User test. Google it. Right, so world corners. Let's give that a go, shall we? See how it goes. So, yeah, we do want to put this behind some kind of if statement, but we'll just give this a go for now. What are you complaining about? Vector 3, vector 3. Oh, there's no color in it. Right, so RGBA8. Cool, so it seems like we're completely inside it in ways. You can see them around the camera. We just need a way to freeze it now, basically. So yeah, I think that's kind of a nice thing about having an AI to do that, right? Is that you could remove the laborious part of refactoring or plumbing something through all these different systems, right? But the only downside I can think of it to that is that will then increase the amount of friction you have in the code base because you can just defer it to the AI to do it. And that means people could live with a lot more um, redundant things or poor design decisions for a long time. And I I guess that would impact the final product as well because it could, you know, there's more code doing stuff, so therefore code base is probably slower, right? More transforms of data, therefore code is probably slower. Yeah, that's the only downside I think of it really. And obviously, if the tool goes behind a paywall and they up the money and all the servers go down, you can't do your work. Yeah, so now basically we need a way to sort of like this world from view, sorry, view from world. We need to have a way to sort of like freeze it. And when we're talking about the culling planes, that it uses the debug one, right? So I guess we just go to graphics VK and we just say let's just be lazy about it for now. Custom planes view from world. So we can call this like occlusion call view from world because we'll probably need that for the yeah, I don't know. Anyways, so by default, you do that equal that. Occlusion call view from world. And then you simply just say, so I think we've got a packet thing. Where is it? Yeah, so if we press right control, let's say that. So if OS keyboard has been pressed, payload OS packet, virtual keyboard. There'll be right control. We press the right control, then that will freeze. Stack ball Yeah, something like that. So that will allow us now inside the shader. I think. No. We're talking about the frame in it, isn't it? Yes, the view from world in here, yeah? Alright, so that should freeze it now. Or we have the ability to freeze it, okay? See what happens. So we press the right control, freezes, and I move it. Bum bum bum. There we go. Yeah, it seems like then the frustum code, like the thing that makes the frustum planes is probably fine. Maybe not though. But at least we can do this now. This is cool. Yeah, something about it where it's just completely messed, and we need to figure out what it is. But this will be extremely useful to help debug yeah, the whole system basically, to make sure it works fine. Cool, it's a good place. So, put a pin in it today. But yeah, thank you for everyone coming by. There's a YouTube channel, by the way, if you want to see the video going over like what the project is, where we're going, what the plans are, you can check it out on the YouTube channel there. And the VODs do go up on there if you want to watch the stream back again, you can do that. You can come join the Discord channel and come and hang out in the meantime. And hang on. And there's a way to support the channel to get access to the codes to run on your own local machine. Thank you for everyone who's supporting the channel. Appreciate you all. But yeah, thank you so much, Theron. Appreciate you. Sorry, Therion. But yeah, I'll be on. So Tuesdays, Thursdays, and Sundays, 7:30 p.m. GMT +1, and Fridays is a 2 p.m. GMT +1 stream as well. Yeah. Hope you have a good Wednesday. Hopefully see you all Thursday. God bless you all. Catch you later. Bye bye.